So now that we have this map that maps basically that takes a point in the feature space and outputs a given confidence, we can use it to see how the data changes in the data distribution. So the covariance shift actually impacts performance. What you see here is that, let's say that on the test data, we have the same behavior as before. So the data is distributed in this kind of Gaussian way. And as we deploy our model to production, our data becomes much more concentrated in the 0, 0 region, which means that we would actually expect to see a drop in performance because the average confidence of the model will go down because there's less information in the data, right? If you're right at the class boundary, actually where two class boundaries almost meet, so in this region, it's really impossible to tell whether the model prediction is going to be, sorry, the actual target is going to be positive or negative. Even us as humans wouldn't be able to tell because the data is a bit noisy there. So we can then, if the data drifts to regions that are more uncertain, when we just have less information about the actual mapping between the model inputs and the targets, we expect to see a drop in performance. Now, kind of on the opposite side of the spectrum, if we see a drift to certain regions or to similar regions to the ones we've seen that the model is confident about, we expect to see, generally speaking, a slight increase in performance or at worst, no change in model performance. So even though we observe very strong drift that would be visible both in univariate and multivariate drift detection methods, there is no impact on model performance. And if anything, the impact is actually positive. And then last, in some ways, most severe way that covariate shift can impact model performance is drift to unseen regions, when the data is going to drift to a region that was not adequately represented in the training data. And what we see here is that, again, we see expected drop in model performance because the model will likely not generalize well there, and the model itself is actually correctly inconfident about its predictions. So we expect to see a strong drop in model performance.